Physics Lab for Oscillations. In this lab, I examine the motion of a spring mass system in which the mass swings in an arc while oscillating on the spring. We have two fundamental principles in this lab, Newton's second law and the energy principle. Put a video of the observations of a mass into Tracker to gain data about the mass's movement. Using the data, I set up the Python code with given data from WebAssign and the data from Tracker to create a model. As a result, I was able to predict the motion of the spring with slight error. As well, the system satisfies the energy principle. As said before, we have two fundamental principles used in this lab. Newton's second law, which is written as the final velocity equals the initial velocity plus the net force divided by the mass multiplied by the change in time. This fundamental principle is used in the computer model to find the position of the mass while it oscillates on the spring. The energy principle, written as delta E equals the change in kinetic energy plus the change in gravitational potential energy plus the change in spring potential energy. This principle is used to find the change in the total energy of the system, in which if the lab is done correctly would equal 0. Once the video was uploaded, we set the axes in the calibration for how long the static spring was. We then tracked the motion of the mass. Using the data collected, I graphed the data for the oscillations in the x direction, then the y direction, which is shown. Using the given values from the videos and the data we just obtained from Tracker, we are ready to start our code. These values shown are used to initiate the code. We also need to calculate the spring constant and the change in length of the spring. After finding the spring's oscillation period as 1.654 seconds, I used the derived equation Ks equals 4 pi squared multiplied by the mass all divided by the period squared, which was found to be 6.88 kilograms meters divided by seconds squared. Then I used another derived equation shown as the change in length of the spring is equal to the mass times the gravity, all divided by the spring constant, finding the change in length to be 0.127 meters. Now we are ready to use the fundamental principles in our code. First we find the stretch of the spring, which is the magnitude of the difference in the ball's position and the string's position, minus the initial length of the spring. Then I calculated the energy of the system. The kinetic energy equals 1/2 the mass times the velocity squared. The gravitational potential energy equals the mass times gravity times the height of the spring. The spring potential energy is equal to half the spring constant multiplied by the stretch of the spring squared. We will use this information in the energy principle in our code. Then I calculated the mass's position using Newton's second law. Using the net force calculated, I found the final velocity. Since the net force does not equal 0, the final velocity equals the average velocity, which was used to find the mass's final position. Then to calculate the change in energy, I calculated the changes in kinetic and potential energy and totaled them to find the total change in energy of our system. Running the code, the blue ball is the computer model and the red ball is the tracker data. The spring system moves in elliptical motion. The blue arrow is the spring force, while the black arrow is the gravitational force. The two data sets look nearly identical, with slight difference, which is caused by the drag force affecting the spring and slight rounding error in mathematics. This next run code is the graph of the energies in our system. The blue line is the change in kinetic energy. The red line is the change in spring potential energy. The green line is the gravitational potential energy. And the yellow line is the total sum of the change in energy, which is equal to 0. What does it mean, question 1? The energy principle is satisfied because all the energies in the system are accounted for and conserved, leading to a total change in energy to be 0. The kinetic energy will cancel with the potential energy of the system. This is shown in our graph by our yellow line representing the total change energy, which is equal to 0. What does it mean? Number 2. I plotted the oscillation positions of the data for the x and y directions. As shown, the periods of the oscillations are not the same. Periods are different because the x direction is derived from the length of the spring and gravity, while the y direction is derived from the mass and the spring stiffness. In conclusion, the computer model predicts the motion of the spring very well. Also, the spring mass system satisfies the energy principle. Thank you very much for watching.